Hi everybody, on today's show, our 47 minutes when they expired, you should be able to solve linear equations. This is basically a crash course of your unit of solving linear equations in 8th grade, so let's get to it. Try this opening exercise, pause the video and see what you can do. Solve this linear equation. So take a second, see if you can solve this linear equation. So hopefully you noticed the first thing you had to do was apply the distributive property. You had to take the 3 and distribute it over that addition there to get 3t plus 12, 3 times t, 3 times 4. And then you have to apply the distributive property again, but be careful, you're distributing a negative 2. You're not distributing a 2, you're distributing a negative 2, which gives you minus 4t minus 6 equals negative 4. So we applied the distributive property twice, and now we're going to combine like terms. So I have 3t minus 4t. Well, that gives me negative 1t's. And then I have 12 minus 6. That gives me positive 12 equals negative 4. Well, using the addition property of equality, I can subtract the 6 from both sides, which leaves me with negative t equals negative 10. Well, if the opposite of t is negative 10, that must mean t equals 10. I can divide both sides by negative 1. So t equals 10 is our solution. So consider this linear equation here, 3x plus 4 equals 8x minus 16. Let's solve this for x. Well, this equation looks very different than the other equations we've been solving. It looks different because I have variables on both sides. So when we have variables on both sides, our plan is to get a variables on one side and no variables on the other side. So get everyone with the variable we want on one side, everybody with the variable we don't want on the other side. And there's plenty of ways to solve these equations, and we're going to see that there's different starting points that you can do to solve this one equation here. There's 4 different good starting points, and the first one I'm going to have you do is subtract 3x from both sides. So using the addition property of equality, I can subtract 3x from both sides. That goes to 0, and I get 4 equals 5x minus 16. Now, isn't that those two-step equations we solved yesterday? Well, let's get x by itself. It's being multiplied by 5 and then subtracting 16, so let's get rid of the 16. That way, everyone without a variable is on this left-hand side of the equation, and my variable is isolated, more isolated on that side. Well, I don't care about 5 times x, so I'm going to do the inverse of multiplication, which is division, and I get 4 equals x. That was one possible way to start solving this equation. Another option is you could have subtracted 4 from both sides. There's lots of legal things to do here. Maybe you said, I don't like this plus 4. I'm going to subtract 4 from both sides. It's a legal start. 3x, those go to 0, equals 8x minus 20. Well, I have my no variables on this side, so that means this 8x has to get moved over. How do I undo that positive 8x? Well, I use the addition property to add negative 8x to both sides. 3 minus 8, please be careful with your integers, folks. You have a calculator to help you out there if you're confused with your integer operations at this point. Then I can divide, and I get x equals positive 4 again. This should not be a surprise because we already solved this equation. Let's solve it again. This time we'll solve it by subtracting 8x from both sides to start with. So as you see here, there's lots of different choices for getting started on these equations where you have variables on both sides. Once you get to something like this, there's 4 options you can go with. Let's try subtracting 8x. So let's subtract 8x. Let's move my variables over to this left-hand side. Negative 5x plus 4 equals negative 16. I'm going to subtract 4, because this is a nice two-step equation now. And we appear to be always ending at this point of x equals 4 once I divide by negative 5. And one last time, in case you haven't figured it out yet, that x equals 4 is the answer. In case you didn't know that x equals 4 is the answer, one last time. The only other option you could have done is added 16 to both sides. 3x plus 20 equals 8x. Well, let's get all my variables on the right-hand side here by subtracting 3x. So you just have to make a decision. What side are my variables going to? Am I going to put all the variables on the right side, or am I going to put all the variables on the left side? And once you make that choice, you've got to stick with it. So 20 equals 5x. Well, 5 times, this equation is literally saying 5 times what gives me 20. 5 times what gives me 20? 4 times 5 gives me 20. So I've got a bunch of linear equations here. I believe there's 6 of them. Stop the video, start solving them and see how you do, and then compare your work with what I did here. You're going to have to use the distributive property. You're going to have to be careful, but see if you can try solving these linear equations here. So let's get to it. In this first one, I see I have variables on both sides, so I'm just going to start by using the distributive property. 5x minus 15 plus 2x equals, I have to apply the distributive property again, 4x plus 12. Okay, well, let's look at this left-hand side here. I can combine these x's together. I have 5x and another positive 2x. That gives me 7x minus 15 equals 4x plus 12. Well, this equation I ended up here has the structure as the one that I solved before. So I'm going to make a choice. I'm going to subtract 4x from both sides. I don't know why I made that choice, maybe to keep my x's positive. But I made a choice of subtracting 4x. Maybe you made another one, but we're going to end up at the same spot. So now this is a nice two-step equation. I'm going to add 15. 3x equals 27. Well, 3 times what gives me 27? That's what this says. 3 times some number gives me 27. That number is 9. You could have divided both sides by 3 as well. Ooh, this next one's so tempting because when you look at it, you're like, ooh. 9 minus 6 is 3. We cannot start there. We cannot start there because the first thing that we need to do is before we subtract, we need to apply the we need to apply the distributive property. I'm taking a negative 6 and distributing that into this equation. Into that, sorry, that's not an equation, into that binomial there, that expression. So 9 minus 6y minus 6, applying the distributive property times negative 6 times negative 6. Apply the distributive property again. Okay, I applied the distributive property, but now I got to clean up. So let's focus on this side of the equation here. What are my like terms? I have 9 and a negative 6. 9 minus 6 gives me 3. Let's look at this side. What are my like terms? I have a 2y, and when I combine those, negative 8 and 27, that gives me 19. Let's add 6y to both sides. Again, I have lots of choices at that step I just made right there, but I chose to add 6y to both sides. Well, how do I solve for y? I'm going to subtract for 19. I want to isolate that variable. Think of those inverse operations at this point. And then I have 8 times y. How do I undo multiplication? Division. Correct. Negative 2 equals y. That is my solution. Again, I could check these, but I'm not going to waste my time doing that because I have a lot of other equations to solve. But if I gave you one equation, please check it. If I, on a test or something, said solve this equation, please check it by substituting back in. Oh, this next one's beautiful. We have decimals, fractions, all that good stuff. Well, let's see what we can do. Well, let's focus on this side of the equation. Let's look at that left-hand side of the equation. It appears that I have like terms right there. It appears that I have like terms. I have negative 10.5x plus 7. Please use a calculator to check your decimal arithmetic. Please, please, please. Equals, okay, we're applying the distributive property again. I'm taking that negative 6 and distributing it into that binomial. 1.5x minus 6x, negative 6 times negative 3 halves. Negative 6... Negative 6 times negative 3 halves gives me positive 9. Cleaning up this side a little bit more, I end up with 1.5x minus 6x. I believe that's negative 4.5x's plus 9 is the same as negative 10.5x plus 7. I'd rather deal with positive x's, so it's going to affect my first move here. So 7 equals something plus 9. How many x's do I have there? I can go to your calculator to check this out. You have 4.5 of them. You're subtracting away, you have 10.5 of them, and you're subtracting away 4.5 of them. That leaves you with 6 x's. Subtract 9 from both sides. Negative 2 equals 6x. Well, that's a little bit weird because I'm going to end up with a rational number, a fraction, as my answer. So what's the rational number? That's the answer. Negative 6 over 2. X equals negative 2 6. But we better know that is negative 1/3 if we simplify that fraction there. How do I check that that's actually a solution? Take it and plug it in. Sliding on over here. I've got variables on both sides, so I'm going to use the distributive property to get me started. Negative 1.5x minus 12 equals 1.5x minus 1.2. I'm going to subtract 1.5x. That adds to 0 as well. That's interesting. And I get negative 12 equals negative 1.2. Wait a minute. This is always false. So if this is always false, that means that was always false, which means that's always false. So because that's false, the original is false. So what's the solution for x? What value of x makes this true? There are no solutions here. So whenever you end up with a nonsensical statement like 7 equals 4 or negative 12 equals negative 1.2, notice that you end up with no solutions. You end up with no solutions when you end up you end up with no solutions when you end up with a number sentence, negative 12 equals negative 1.2. When you end up something ridiculous like that, notice your answer is you have no solutions. That equation is never true. No value of x when plugged in makes it a true statement. Hopefully you're a master of the distributive property at this point. Multiply by 8, multiply by 8, multiply by 2, multiply by 2. Wait a second. 8j minus 32 equals 8j minus 32. Isn't that saying the same thing on both sides? So there are infinite solutions here. Any number will work. Any number will make it true. So I can substitute in any number, and I'm going to get a true statement. So that means there's infinite solutions to this equation. So notice here, I had the same things on both sides. 8j minus 32 equals 8j minus 32. That gave me infinite solutions. Here I had the same x terms, 1.5x and 1.5x, but those numbers were different. That led me to no solutions. Hopefully you remember that from 8th grade. You should have spent some time looking at that and noticing how it relates to the graphs of, if I was to look at these as functions. Moving on over to this last one here, I see I have t on both sides, so I'm going to start by distributing. Please use a calculator if you're not confident with your decimal skills. Distribute again, 0.6t minus 6 minus 4. So there's nothing I can clean up on this left-hand side. So 8/10 t plus 2/10 equals 6/10 t minus 10. I'm going to subtract 0.6 t from both sides, which leaves me with 2/10 t plus 2/10 gives me negative 10. Well, I need to isolate t, so how do I get t by itself? I'm going to subtract 2/10 from both sides. So 2/10 t equals negative 10.2. When I divide by 2/10, how many groups of 2/10 can I make from that? I can make a negative 51. So I end up with t equals negative 51. So these last three here are just kind of get us thinking. Solve this equation by first applying the multiplication property of equality. So if I'm looking at this equation, 7 minus 2/3 x equals x minus 8. I can solve this like I solved the other ones, but if I have a denominator of 3, if I have a 2/3 x there, I'm going to scale this entire equation up by 3. I'm going to multiply each term by 3. 3 times 7 is 21. 3 times 2/3, well, I multiplied by 3 to get rid of that denominator of 3. 6/3 is really 2. equals 3x minus 24. In our first lesson together, we said you can multiply an equation by whatever number you want, and you don't change the solution set. So now I can solve this, and it's a little bit nicer because there's no fractions as coefficients. 21 equals 5x minus 24. I got a nice two-step equation here to solve. 45 equals 5x. 5 times what gives me 45? Well, 9 times 5 gives me 45. And if you solved it by using just that technique that we learned in this lesson, you're still going to get 9. I think multiplying by 3 is a little bit quicker. Consider this equation. Describe the property used to convert the equation from one line to the next. So I started here. This is our start. I want to know what happened as we go on line from line here. So how do I start from here to here? Well, nothing changed there, but it looks like I applied the distributive property. 3x plus 6, they distributed -2, good. And then it looks like they combine like terms here, which is really the commutative and associative properties. That's combining like terms. They combine like terms together there. How do I go from here to here? Well, I subtracted x from both sides. That's the addition property of equality. If I subtract x from both sides, that's the addition property of equality at work here. Oh, and then it looks like they subtracted 7 from both sides. That's the addition property of equality again. And then they divided by 3. Well, dividing by 3 is really multiplication. Dividing by 3 is really multiplication, so I end up with the multiplication property of equality. So it's always good to be able to read through someone else's work to see what they did in solving an equation, which is what we practice here when Kimberly, you made an error solving this lovely equation here. Let's see what she did wrong and solve it correctly. So when I see this, I'm thinking, okay, I got to distribute here. -3x plus 3, good, she did that right. And then she combined like terms, that's good, so those are good. Aha, right here, that -1 needs to get distributed, and it didn't get distributed right there. That should really be 3x minus 11 plus 3x equals x plus 19. That's where Kimberly went wrong, was with that distribution of the negative. Be careful. Don't be Kimberly. 6x minus 11 equals x plus 19. Subtract x from both sides and add 11. That leaves me with, well, it's really 1x. 5x went to 0 equals 30. Well, if 5x equals 30, that means x equals 6. So explain the error. Kimberly explains, use a sentence. Kim did not use the distributive property correctly. That was lesson 3. Hopefully this was a nice crash course in solving linear equations. I'll see you in the next lesson.